Hello, my name is James Roach. I'm a senior electrical engineer at the University of Scranton, and the purpose of this video is to give a brief update to the Autonomous Deliverer, which is my senior design project. In my last video, I basically just introduced the Autonomous Deliverer and what it was expected to do. And the purpose of this video is to basically enhance upon that in terms of the hardware we used, a microcontroller, what we plan on doing with the design of it, and basically a work breakdown structure. So the Autonomous Deliverer is basically a model warehouse system where multiple robots in our warehouse, we plan on using 3, well, they will intercommunicate with each other in order to essentially have a package when it's expected to be shipped, for that to be scanned, it read through a database, and then put it in a delivery shelf according to that expected ship date. And there will be various ship dates, such as 1 week, 2 weeks due, 3 weeks, and 4 weeks on, all in various spots throughout the warehouse. And the jobs of the robots are to, as I previously said, to simply scan them, tell the database, get from the database where the expected ship date is, and then organize it on the delivery shelf corresponding to that. And then, based upon that, to organize a shelf and then have a specific bot just used for the delivery purposes to put it in the delivery docking station. Now, with regards to hardware, I, in the previous video, went over the chassis we planned on using, which was a partly enhanced micromouse. But in my previous video, I did not mention the microcontroller or any type of motor drivers that we plan on using. So the microcontroller we plan on using is a Raspberry Pi. We could have used an Arduino or a Dragon board, as was partly suggested to us by our professor. But the reason we simply chose a Raspberry Pi was familiarity with it and also familiarity with documentation. Also, some specs with the Raspberry Pi that's important, such as GPIO control, or general purpose input-output control, which is essentially used for sensor and motor control. It also has a 900 megahertz ARM Cortex A7 quad-core CPU, along with 1 GB of RAM. And importantly for us, it allows access as a Wi-Fi dongle, or it'll act as a wireless access point using the Wi-Fi dongle. And this is important since the terminals we have on campus at the University of Scranton do not have an HDMI port, so working there, we would essentially need a Wi-Fi module for it to be able to be written code-wise and saved to the Raspberry Pi itself. And this is done through a tutorial on Adafruit. And lastly, with regards to specs on the Raspberry Pi, it is a Linux-based operating system. So for driving the motors, we will have 2 DC motors, 1 stepper motor, and 1 servo motor. And in order to drive these, after doing some research online for the Raspberry Pi on Adafruit.com, we found a DC and stepper motor hat, which consists of full PWM speed control, and it contains, based upon what I just said, a fully dedicated PWM driver chip to control the motor direction and speed over I2C communications. And within this, it has 4 H-bridges with 1.2 amps per chip, so it can run motors on 4.5 VDC up to 13.5 VDC, which will be plenty for the very low power motors that we have given to us from the Micromouse chassis itself. Now, the programming language you plan on using is either C or Python language, depending on further research and familiarity with it. The emphasis is leaning towards Python since there is some background in it, and for the sake of time with trying to learn a new language. And with this, intercommunication is also involved since we plan on having, or we, for better words, are using a computer science, I believe, minor to help us design the database collection. for when package 1 is to be shipped and how many weeks is left for it to do. So he will be helping us in Python design that, and with essentially any other code that we might have. Now, for the design of it, the hardware floor, as I mentioned in the first intro video, it's been slightly modified from that, since it is a basic warehouse, except there'll be we have a shelf in the middle area, which will be a break between delivery area 1 and a delivery area 2. So how the packages will be gone to is with a line follower circuit, or not a circuit, but a line follower diagram on the floor itself. So the robots can go and it'll detect the line, so depending on if there's a package there or not, per the sensors and the database, it'll be able to turn and scan the package and just follow the line and then move backwards and then put it where it belongs on the delivery shelf based upon that. The area with this line follower is that hardware will have to be added onto it with a line following circuit, which will be gone over in a separate video itself, and the database in more detail with regards to code and how that will be designed, which will also be gone over in a further video. Now, with regards to what has to be done, a work breakdown structure has been come up with, and I will read that off right now with the basis of what still has to be done. First, the warehouse still has to be constructed. The design has been done, and materials have been noted, but they still have to be bought. And then, obviously, based upon the materials, the design, based upon the specifications for the floor, that has to be built and then painted white due to the line follower aspect, since we plan on having black tape for the dark area of the line and then white for the voltage level off of that. The physical construction, as I just mentioned, has not been completed since the materials still have not been bought. The detail has not been added either, but it will be, and the final solidification also still has to be completed. With regards to the line follower, since that will have to be implemented, a design has to be created, which it is in the current works of. Basic testing has been done, and a breadboard circuit still has to be made and tested based upon that, and then soldered onto a perf board. The materials have been made, or will be accessed for that based upon if it works or not, which will be mentioned in the next video. And then the chassis for the micro mouse has been found, and the only issue is that the microcontroller and the motor head, along with the line following circuit, will have to be added onto that somewhere. And the key element to this is for it to be balanced, since the elevator for the claw still is fairly top heavy, so it will most likely go on the back of the micro mouse in order to counterbalance that. But lastly, another hardware aspect that I did not mention but I will mention now is that a barcode scanner, which has been found, and it is simply a camera-based barcode scanner, and that still has to be tested with regards to how it will actually work and with regards to the database for scanning a specific package, and then pending what that package said for it to be scanned and then read through the database. And most importantly, the communications aspect still has to be worked on, since some issues have arisen with the intercommunication aspect, since first one micromouse is only completed as of now, or I should not say micromouse but delivery bot, so a second still has to be added, and then communication between them, and then based upon that add a third one in and test the communication from that, and hopefully they will work. And for now, that is it for this video update. The next video update, I will be going over basically another update as to progress, the line following circuit, and I believe that is it if not any more progress has been made. So thank you, and I will update you soon.